Okay, 5.2, we want to figure out how to find out eigenvalues. So we got this one, right? So to find out eigenvectors, we try to solve that homogeneous system, a minus lambda I times x bar equals 0 vectors. And in order to have non-trivial solution of this homogeneous system, determinant of a minus lambda I must be 0. So here we got clue for finding lambda. So here's the strategy. I mean, before going further, we wanna see a couple of the property of the determinant. So if we row reduce the matrix A minus lambda I, so we got the upper triangle matrix echelon form, then determinant of determinant of what? A minus lambda I, right? Sorry. Yeah, or simply, let's say U is the echelon form of matrix A. Yeah, then we can say just determinant of A is equal to -1 to the r's power, and then the pi is the product. Okay, this is the sigma is the summation, right? The pi is a product of U1 through n. Okay, so R means the number of row interchange, and then U sub I is the main diagonal entry of the echelon form. Okay, when we assume A and N is row equivalent to the upper triangle matrix echelon form, okay, then we got this one. So then now next one, I mean, so yeah, so what if if A is not invertible, then what? Determinant of A is simply 0. Okay. All right, so next one, see example 1. The A matrix is given as 1, 2, 0, and 5, 4, -2, 0, -1, 0. Okay. So yeah, let's find out determinant of A. So then let me do row reduce. Okay, let me just row reduce of this matrix. Then we're gonna get a 1 and 5 and 0 and the 0 and the -2 and 0 and then 0, 0, 1. -1, I'm sorry. Okay. So here we perform the lower interchange once. Okay. So here R must be 1. I mean R is 1, number of interchange is 1. Okay. Number of interchange 1, because we reduce the interchange the second row and third row when you get the EF. Okay. So now then determinant A gonna be -1 to the first power times 1 times -2 times -1. 1 times -2 times and then -1, which is -2. Right? Okay. But there are other way to get the EF, right? So let's say if you say this is U2, U1, you should have other way to get the echelon form saying U2. Then you're gonna even you get the U2, which is other than U1, you're gonna get the same determinant. You should get the same determinant. Okay. And let me just review the property of determinant, which is theorem 3. Says that A is invertible. First one. M by M matrix is invertible. If and only if what? Determinant A is not equal to 0, right? Then second one, determinant of AB is equal to determinant of A times determinant B. Third one, the determinant of A transpose is equal to determinant of A. Okay, keep in mind that. And then determinant of triangular matrix is what? The product of the main diagonal entry, right? Okay. So now then there is two more the statement in theorem 3, but just look at the textbook. It says that determinant of triangular matrix, let me say just U is equal to product UII. I goes 1 through n. So here U is triangular matrix. Okay. And then the determinant of A minus lambda I equals 0. This is called the characteristic equation. Okay, of A, matrix A. Okay. So example, this is just simple calculations. Let me skip the example for this one. But next one is, I mean, okay, when you find and determine this one, definitely you're gonna get the polynomial. Okay, that is called the characteristic polynomial. Okay, this one. Then next one is similarity. This is yeah, I think we now start to journey to have the singularity composition. Similarity. Okay. So if two matrices are similar, let's say if A is n by n matrix and B is also n by n matrix. So then A is similar to a matrix B if there exists invertible matrix invertible matrix P such that what A is equal to a P inverse times A times P is equal to B. Okay. So or equivalently A is equal to what? P times B times P inverse. Okay. That's the in that case we say that A is similar to B. Right. So the changing, here's a note. A into P inverse times AP. This is called a similarity transformation. All right, so here's the theorems. See, I mean, okay, so what's that mean? Why we need to do this? Because we eventually we want to express matrix A as invertible matrix P times diagonal matrix times inverse matrix P. Okay, so that we can easily figure out the eigenvalues, because once B is diagonal matrix, then what's the eigenvalue of A? The diagonal entry of that diagonal matrix, it would be the diagonal matrix, matrix. Okay, that's why we need that concept. But yeah, so here's the theorem, by the way, theorem. Or so if two matrices are similar, then they have the same characteristic polynomial and hence the same eigenvalues. You wonder that if I said that if B is a diagonal matrix, then the eigenvalues A is nothing gonna be diagonal entry of that diagonal matrix, right? Why? Because of that theorem. So if n by n matrix, I mean A is n by n, and B is n by n matrix. Okay, they are similar and are similar. Okay, then they have the same characteristic polynomial, which means that they have the same eigenvalue. Okay, so here's a proof. So if B is P inverse and A P, right? Then B minus lambda I is equal to what? AP, right? A P inverse, sorry, minus lambda. And the I is we can express I as a P inverse times P. Is so now P inverse is a common factor. So factoring out. So we got A P inverse times AP minus lambda P. Right? And then P is also the common factor. So we can factor out to the right because P is a right multiplication. So P inverse times A minus lambda I and then P. So now we find out determinant. Determinant of what? B minus lambda I. Let's find out B minus lambda I. Determinant is equal to what? Determinant of what? P inverse the lambda A minus lambda I times P. But you know what? We can decompose that determinant as product of determinant, right? Determinant of A minus lambda I, determinant of P, right? But you know what? Determinant of what? P inverse and determinant P is what? We can combine these two determinant, right? So this is equal to determinant of what? P inverse and then P, the determinant of A minus lambda. So what's that? 1, right? Because P inverse P is an identity matrix. So determinant identity matrix is 1. Proof is done. So that's for 5.2. Okay.